Hi everyone, this is Bhupendra Singh. Today I am demonstrating to you how to test and communicate between two long-range LoRa RF SX1278. LoRa core is patented and manufactured by Semtech. The series of LoRa SX1276, 77, 78 and 79 transceivers featured the long-range modem that provides ultra-long-range spread spectrum communication and high interference with minimizing current consumption. So where we talk about the application, you can use LoRa in any application where you don't want to use a public network because it creates its own network. Nowadays, LoRa is widely used as an IoT gateway for industrial application. The range of this LoRa module is near 1 kilometer. So let's start with a demonstration. This is the circuit diagram of LoRa transceiver module where we use it with Arduino Uno as a transmitter. And this is a receiver board circuit where we use a 20x4 alphanumeric LCD display with an Arduino. When the transmitter board transmits the data and receiver receives and displays that data to LCD. So this is the LoRa SX1278 transceiver module that is attached with the base patch designed by the Nutty Engineer company. It has 8 output pins starting from the top. First pin is ground, then 3.3 volt VCC, NSS, DIO0, SCK, MISO, MOSI and last RST. We take two LoRa modules, one for the transmitter and another for receiver. This is the customized ATmega328 board which is compatible with Arduino IDE software. This is the SMD ATmega328 IC. These are the programming pins to program it through a programmer. This is the LoRa socket where you attach the LoRa module, and this is the DC power input jack for external power supply through a 12 volt adapter. And this is how we place the LoRa board in the customized board. This is the customized LoRa receiver board. This is also designed by Nutty Engineer company, and this is LoRa module socket. This is an SMD ATmega328 IC. These are the programming pins to upload the program through programmer directly from the Arduino IDE. This is a 20x4 LCD socket where you place the LCD with male pins. This potentiometer controls the brightness of the LCD. This is Nutty Node MCU Wi-Fi that is built in with this board. This is the 12 volt DC jack for external power supply. And these are the programming pins to program the Nutty Wi-Fi board. But we are not using Wi-Fi this time. We are just working on LoRa RF. Now I am placing the LoRa module to the receiver board like this. And this is a 20x4 LCD with male headers. And I am connecting it to the board. At last, this is the CS340 programmer to program these boards. This programmer is also designed by Nutty Engineer company. You can connect it to the programming pins of the boards like this when you want to program this board from Arduino IDE. So our LoRa transceiver boards are ready for testing. Let's have a look at programming on Arduino IDE. But before that, you need to download the LoRa library for Arduino as well as the programming code. So go to the video description and download the LoRa library. Once downloaded, you will get the WinRAR file with the name SME LoRa lib. If you don't have WinRAR or WinZip software to unzip this folder, then a link is available in the video description to download. Now unzip the folder and you will get the unzip file with the same name. Copy this folder and go to the folder where you install the Arduino. Go inside it, you will get the library folder. Go inside this library folder and paste the LoRa library here. Again, go to the video description and download the programming code for this project. Once downloaded, you will get the folder with the name SME LoRa code. When you extract it, and you will get the folder with the same name. Open the folder and you will get two folders with the name SME LoRa RX and SME LoRa TX. So open the folder with name SME LoRa TX and you will get the Arduino file inside it. Open it with Arduino IDE software. So this is the program for the board that is acting as a transmit. First of all, we define the SPI library for Arduino. SPI library is inbuilt library for Arduino, but if it is not available in your Arduino IDE, so then I have given link in video description. You can download and add it to your library. We include the LoRa library and define the LoRa module pins as SS2 10, RST as 9 and DIO0 as 2. We take counter 0 as integer type so that we can send counter value to the LoRa receiver every second. In the setup mode, we begin the serial port at 9600 baud rate. While we start the serial monitor, it serially display the message LoRa sender tested by SME Dehradun. We set up the LoRa module pins by defining the command LoRa.setup pins SS, RST and DIO0. After it, we write the command to initialize the LoRa modem at 433 MHz by command LoRa.begin. If it's found the LoRa module connected to Arduino or customized board, then it displays the message serially that LoRa initializing OK. Otherwise, displays starting LoRa failed. After it, we set the synchronizing word for receiver module so that when LoRa receiver receives the data packet after synchronizing this word. Now inside the loop function, we serially print the counter value and then begin the LoRa packet with LoRa.begin packet function and write inside the packet space counter value. After which we end the LoRa packet with the LoRa.end packet command. We increment the counter every second so that every time LoRa packet sends the incremented value. Now I am connecting the LoRa transmitter board to the computer using a programmer and clicking on the upload button to upload the program to the board. But before that, you go to the tools and select the board as Arduino Uno and also select the port as COM8. You go the COM port after you have pre-installed the programmer driver to your computer. If you don't know about it, then a link is available in the description to guide you about it. As you can see, programming uploading has been done. Now open the serial monitor to check the output in serial. As you can see, the LoRa packet increment value every second as we write in our program. Now time to open the program for LoRa receiver. So go back to the folder and now open the SME LoRa RX program. In the receiver program, we include the LCD, SPI and LoRa library. We connect the LCD pins to A0, A1, A2, A3, A4, A5. Now we define the LoRa pins at SS10, RST9 and DIO0 at 2 number pin. There is no requirement for a counter, so I will delete it. In the loop function, we begin the serial at 9600 baud rate, begin the 20x4 LCD, clear the LCD and write the LoRa.set pins command. We begin the LoRa module at 433 MHz and if it is not initialized, then we write the serial command to print as starting LoRa failed and also print LoRa error in the LCD. And if it initializes correctly, then it synchronizes the set word as 0xF3 as similar to the set in the transmitter and serially write the message LoRa initializing OK. And at the same time, it prints LoRa is OK in LCD. As we are given a delay of 3000 milliseconds here, so it will enter the loop function after 3 seconds. Here we take integer type packet size and store the complete packet. Once the packet is received, then we serially display the message received packet and also in LCD display. So when data is available in the LoRa module, then we take LoRa data as string and store the complete string from the LoRa packet using the LoRa.read string command and serially display the LoRa data string to the serial monitor and also in LCD. After it, we display the RSSI packet power or strength serially as well as in LCD display. RSSI means receiver signal strength indicator. So display the RSSI using LoRa.packet RSSI command in both serial as well as in LCD display. Now I am disconnecting the LoRa transmitter from the laptop and connecting the LoRa receiver board. Select the board as Arduino Uno and select the port as COM8 and click on upload the program button. Program uploading has been done and you can see the output in LCD that LoRa is okay, means our LoRa receiver is working fine. Now time to test the LoRa with a receiver board. So I am powering up the LoRa transmitter board using a 12-volt power adapter. As you can see, the LCD is displaying the packet received from the transmitter with RSSI. Once I power off the LoRa transmitter board, you can see the packet receiving has been stopped as the transmitter is not sending any packet from the transmitter. Again, I am powering up the transmitter. It receives the packet from the starting of the counter from the LoRa transmitter board. This is how you can transmit and receive any data through the LoRa transceiver module. You can contact the Nutty Engineer company to customize any kind of hardware as well as software. Nutty Engineer provides you the complete solution for your hardware and software products with customization as per the customer requirements. Contact information is available in the video description with details. Thanks for watching. Kindly like, subscribe and share our channel and videos. You will get all the updates with complete information and working code in all videos.